My name's Matthew Winter. I'm a program manager for the Azure Customer Advisory team. I specialize in big data, Azure Data Lake, and SQL Data Warehouse. So let's start really with what the session objectives are and the takeaways from this session. I want to initially go through and give you an understanding of what a data lake is and position that within your data strategy. And then after that, I actually want to go through the big data Lambda architecture and how we can solution that within Azure. How many of you out here know what the Lambda architecture is? Okay, that's a few hands there. That's good. And of course, I want to go through all of the different services that we actually offer within Azure and contrast and compare them. Because one of the biggest questions we always get asked is, why is there 3 ingestion models? Which one would you advise me to use for this particular project? And that's what I want to go through today. So first off, let's start with the big data evolution. Now, when you start looking at Hadoop and how that actually came about, it really came about as a batch layer, as a big volume of data, batch processing system, and then evolved into more real-time data ingestion, real-time event processing, and then further, and since then, it's actually moved towards giving you kind of predictive analytics, machine learning, deep learning capabilities. Now, here are a couple of examples of how this has been used within Azure. First off, I just want to show a data sandbox environment. This is the Virginia Tech. They host petabytes worth of data on HD Insight, and they actually perform genome sequencing on HD Insight. Now, when they were on-prem, this used to take 2 weeks to run one sequence. When they move this into the cloud, they're now running 20 sequences per day. And that just gives them the kind of scale that they were able to achieve by moving into the cloud. It also means when they're not actually wanting to perform those tests, they can actually turn the cluster off and save on the cost of running them. Another example, and probably the one that most of you here will be more interested in, is around how you can use big data within the business intelligence world. A lot of people they want to ingest the unstructured data, they want to ingest streaming data, and they want to use that to perform transformation and then move that into some form of presentation layer where they're doing the traditional business intelligence. Now, this example here is Carnegie Mellon, where they were actually taking data from sensors. They were moving this into a combination of HD Insight, SQL Server, and Power BI. And they were using this really just to see how they could actually lower their consumption of energy. And they were able to achieve, just by doing this, 30% decrease. And our final example, this is based out of the US. So Ziosk make tablets for restaurants. To give you that kind of on-table interactive display that they're, in this example here, they're using it for Chili's restaurants in the US, where they're able to make, the individuals at the restaurant can actually place their order through the tablet itself. And as the individuals might be hovering, say, on certain items, they can make recommendations, they can put forward discount coupons, etc., to try and literally just get them to buy more products from them. It can also be used to provide extra capabilities. So you want to provide the ability to change music within your booth, you could do that through this as well. So let's move into getting a feel of what a data lake is. Now, throughout the past year, I've been constantly asked these 3 questions. Basically, I'm not sure my architecture is correct. Can you please take a look at it? Is this right for my business? Is this right for the strategy that I'm trying to achieve? Should I be using product X or product Y? You've got 3 products there for ingestion. You've got 2 products there for streaming. You've got 3 products there for storage. Which one should I be using? And then, of course, we've gone through the process of building out a big data solution. And now we're just finding that it's just not performing. Can you come in and identify what we've done wrong? So based off of that, we've really put together the following core principles of what we see as a successful Azure big data architecture. First one being is to decouple the data bus. Second, of course, is to follow the Lambda architecture. Now, the Lambda architecture has been around for many years. This has just been extended to take into account the Azure services available. And of course, the third one, choosing the correct tool. It's really important that you select the right service, or at least to, set up an architecture where you can actually swap out services if you actually choose the wrong service. And that's actually, that then leads into the importance of making use of managed services. So, decoupling the data bus. So let's look at a traditional Hadoop system. So if this was a Hadoop cluster on-premise, there's a lot of things that you'd have to make a decision around. You'd have to scope out what that cluster size is going to be. You're going to have to physically actually build it, configure the hardware. You're going to have to set up teams to actually administrate this. You're going to have to add the data, and then, of course, build out the queries. Now, that could take several months to actually achieve that before you actually even start seeing any data and getting any benefits from it. But then, say, within 180 days' time, you suddenly find that your 2 compute nodes has run out of storage. You now need to actually expand that to get any benefits from it or continue using the system. So then you might go from 2 nodes to 4 nodes on day 183. That gives you plenty of storage. It also increases the amount of compute that you're getting. And users start seeing that they've got more compute, they start adding more queries, they start running more jobs, and then suddenly you get the opposite, where in, say, day 400 in year 2, where you've actually progressed down this path, you're now actually using far more CPU than you are compared to storage. And so then you start having to think about expanding based on the actual compute capacity. And again, on day 401, you might double that from 4 nodes to 8 nodes. So really, one of the key principles when you move to the cloud is actually decoupling that data bus. And we do that essentially first off by putting in a big data storage layer. Now that big data storage layer, it could be Azure Data Lake Store, it could be Azure Storage. There's many different offerings there. On top of that, we would put in our compute. Again, we've got many different offerings there within HD Insight, whether it's Cloudera, whether it's Hortonworks, whether it's MapR, all of which can run on top of this big data store. And not forgetting the ingestion. We're going to have bulk ingestion, we're going to have event ingestion. Both of these are really important to the actual architecture. And then finally, we have discovery and visualization. Now, most people miss discovery. This is really about making it super easy for people like data scientists to start using that data, finding where the data is located within that big data system, and actually finding the gems from the information that you actually are going to need moving forward. And the visualization is the opposite. That's for your typical business users, where they don't want to have to know how to go and drill it down and where the data is located. All they want to do is run reports. They want to do slice and dice style analytics, and that could be Power BI, Tableau, or one of the others. All of which has to be part of this architecture. So let's just attach a few products. I know everyone loves to attach products to these slides. And we're going to walk through each of these during the next hour. We're first going to start off with, of course, the Azure Data Lake Store. Now, how many in the audience have used the Azure Data Lake Store? Okay, that's a good few hands. So essentially, the Azure Data Lake Store, this is our hyperscale, built for analytics, no limits, stores any form of data, gives you enterprise-grade access controls, encryption at rest, etc., provides web HDFS interface for all of the usual Hadoop tools, and of course, most importantly, it's optimized for the analytic workload. Now, I'm sure there's a few of you are wondering if this is coming to Australia or whether or not I'm going to be making an announcement. I'm not. It is coming to Australia. I can't divulge when that might be. If you wish to have a conversation with me after the talk, I might be able to give you more information. On top of the Azure Data Lake Store, you might put the Azure HD Insight. Now this has been around for a number of years now, so this is fully 100% open source. It's based off of the Hortonworks data platform. We've worked very, very closely with them to actually increase the service level agreement, give us maximum uptime with minimum actual issues with the actual product itself. We've also been increasing the amount of or type of services available. So we recently introduced Spark 2.0 on Linux for you to make use of. We've also introduced Kafka now under preview within HD Insight, and we'll be actually increasing that list of services as we go throughout this year. And then finally, the Azure Data Lake Analytics. So the best way of thinking about this is execution of jobs as a service. So we basically provide a Yarn cluster where you can actually execute your jobs. These jobs are specifically built using USQL, which is essentially a mashup of T-SQL and C#. Gives you full extensibility, fully integrated with Visual Studio. And literally, when you actually execute one of these jobs, you actually specify the scale that you want to use. So that could be 1 vertices, or it could be 100 vertices, which are equivalent to nodes. And on top of that, we also provide the ability to perform federated queries across different data sources. And what that means is we can actually use USQL to execute queries against data where it lives. Now, the point about this is you don't have to move that data. You avoid moving large volumes of data, whether that's terabytes of data stored within the Azure Data Store, the storage blobs, etc., just to bring it all together and process it as part of that batch job. So you can reach out to SQL Server on VMs, you can reach out to SQL DB within the PAS option, you can reach out to SQL Data Warehouse and bring all of that data together and then write that out to Data Lake Store or blob storage, which is a real powerful feature when you start thinking about some of these other services could actually be your upstream sources. Other typical scenarios that we see with Azure Data Lake Analytics. The key one really is about extract transformation. Now, everybody who's built a data warehouse will know ETL, and most customers, the very first thing they do is they try to replicate that. It's the wrong thing to do. You really need to be looking at performing, loading the data, and then performing that transformation actually in your big data solution. So essentially, ELT, not ETL. So that's the first thing. And that actually benefits you across all of the Azure data services. Of course, you can use the USQL capability about doing query federation to actually bring that data in. You can process the unstructured data and structurize that, or provide structure to that data. Now, so decoupling that data from the compute, essentially what that's allowed you to do is to start off with smaller components and just pull them together, connect them together like Lego bricks. So in this example here, we have the Azure Data Lake Store as being your big data storage layer. We're actually executing a couple of HD Insight nodes against that Data Lake Store. And then we're using Azure Data Factory to push that data from Data Lake Store to SQL DB and then visualize that through Power BI. Now this would be small volumes of data. But as your data volumes increase, so does your architecture. You may add additional HD Insight nodes. You may move from SQL database to SQL Data Warehouse to make use of the massively parallel processing of SQL DW. In this, you're still using Azure Data Factory. You may double your HD Insight nodes or add Azure Data Lake Analytics to the actual processing, the compute, all running off the same storage layer. And just last week, we actually did announce the use of Polybase from SQL Data Warehouse against Azure Data Lake Store. So that means you can now pull data in from the Data Lake Store in parallel, upwards of 3 terabytes per hour. So moving forward onto the Lambda architecture and looking at the actual individual components. So let's start off with the 4 modules that you would normally see within the Lambda architecture. So on the left, we have the data consumption layer, or the ingestion layers, as some people would call it. We have the speed layer, which is for our event-based processing. We have our batch layer for our batch processing. And of course, we have our presentation layer for the consumption by the users. And we're going to walk through each of these. Now, if you look at then the requirements of building a really good Lambda architecture, these are the 5 key elements that you should be looking for. The first one is scalability. You want to be able to manage any volume of data. As you move forward and progress with your big data solution, you're going to find your data volumes don't just grow, say double each year. They may quadruple each year. They may be 10x each year as you find new sources to actually add and new types of data. Now, every year we find that people are finding new uses for this kind of solution. We have customers using video, we have customers taking audio and actually processing it as part of this kind of solution. Resilience, of course, is a key element. Now that's it's not just high availability of the actual service itself. You want to guarantee that. You want to then look at being able to ensure that this has got full disaster recovery across multiple regions, etc., and that the services allow for that. Low latency. You don't want issues around data movement between these different components, running them together over an internal Azure network will guarantee that kind of low latency. You want extensibility. Or by this, we mean that you want to be able to extend the individual service itself, but you also want the capability to pull out one service and replace it with another. Because as I mentioned previously, you might start off with SQL database, and you might hit the limits of SQL database for your presentation layer, and then move to SQL Data Warehouse as the volumes increase into the tens of terabytes. And finally, maintenance. You want this ideally to be managed services, platform as a service. So, choosing your tool. Let's go through the various different layers, and let's go through the various different and compare and contrast the options that we have in each of these layers. So, event ingestion. So this is our data consumption. It's part of our speed layer as well. When we start looking at the event ingestion patterns, what we tend to have is, on the left, we have our business apps, our mobile apps, our sensors, our IoT devices, all firing off events that are going into services such as Azure Event Hubs and Apache Kafka. Now, there are various different reasons why you would choose one over the other, and we'll touch on that in a second. Those events would then travel into, for stream processing, then that will be done through something like Azure Stream Analytics, Storm, or Apache Spark. Each, again, has their key pros and cons, and we'll go through those as well. And on the right here, as those events get passed through, we also want to be able to visualize it. So we want to provide something like Power BI that gives you that real-time view of the actual events. We also want to store those events, so we need to write out that data to the Azure Data Lake Store so that we can then use that data as part of our batch processing. So looking at the ingestion technology, if we compare Kafka versus Event Hubs, so we recently just introduced HD Insight Kafka. It's in preview, so it's now a managed service. Previously, only Event Hubs was managed. There are differences between the two you can see here. If you look on the right, the throughput for the Azure Event Hubs, that today is limited to 20 throughput units. Now, the product group would love for a customer to raise their hand and say they want more than 20. They want a reason to actually increase that limit. They just decided that 20 was a nice number to start off with, and they would increase it as customers request it. So if anybody wants to go past 20, let us know, and we'll get that to be changed. One of the key areas that we see around these two technologies is Apache Kafka, of course, with it being open source. There's a tremendous amount of information out there in the open source community. This is changing rapidly. You can go on to, say, Stack Overflow, and you can literally pretty much answer any question that you want. If when it comes to event hubs, you tend to be asking that question direct to Microsoft, and you may have to wait a couple of days to actually get a response. It's unfortunate, but that's just the way of the world today. A lot of people are wanting to use the open source technologies over and above the Microsoft-driven ones. But then there are still some benefits for using the Microsoft ones, which are you're no longer having to manage the actual data. So if something like Stream Analytics, for instance, that is really easy to use compared to the open source competitors, and we'll touch on that in a second. Another piece to note on the Kafka is the administration. Even though this is HD Insight Kafka, you will still need to administer this. There's still the possibility that you may lose data. You're going to have to manage that because that data is part of your management piece. We're providing the platform as a service. That data is going to manage disks. You need to manage how you manage that data. So there's administration cost. But it is far, far more configurable. Now, if we look at the next piece, which is the stream processing, now we've got the following three technologies here. So we've got Azure Stream Analytics, Apache Storm, and of course Apache Spark Streaming. Now, Stream Analytics, as I said, it's super easy to use. So you literally just write a SQL-like query, and it's done within the Azure portal. There's very, very little configuration that's needed, building out your own sets of code to actually extend the product or anything like that. All you're really doing is writing SQL. And so really when we look at these three technologies, what we want to be doing is saying, well, actually, I don't know which one of these is going to be suitable for us in the short term. So let's start, and this is my recommendation, let's start with Stream Analytics. Because it's a lot easier to move from Stream Analytics to, say, Storm or Spark than it is to go the other way. Because you would have actually spent a lot of cost and time and money building out the scripts necessary to run on the other two platforms. So starting on something like Stream Analytics, where it's just SQL-based, is really easy to do and really easy to migrate forward. And so that would be my recommendation. The other benefits, of course, are when it comes to Storm and Spark, we're talking about, you can scale this up to any degree. So if you literally have millions of messages that you need to process a second, then you are more likely to be looking at the other two rather than Stream Analytics. So let's look at Stream Analytics and how we can actually scale out the use of event hubs and processing within Stream Analytics. So the key here, and most people forget to do this when they start to go down this path, is the ability to partition your data on Event Hub. If you have one partition and you then run a Stream Analytics query, you're only going to get essentially one thread, one process executing against all that data. You then have to go back and change your partitioning to be able to get any kind of level of parallelism. So really you want to set your partition ID up front and partition your data within Stream Analytics. And that's done as it's shown here within the SQL. So you see where it says partition by partition ID. That gives you the ability to parallelize this query. And in this example, we've actually got 3 parallel processes executing this set of data against Event Hub. So it's easier to do this up front than it is to then go back and change this. Other things to think about is within Stream Analytics, you actually have the ability to execute function calls. Now, one of the things people want to do, and this example is a prime one, is we've got a Twitter feed coming through, and we want to get the sentiment of that text. We can make a call to Azure Machine Learning. Now, what you're forgetting here is that every single message coming through is going to have to make a call. So suddenly, something that might take 1 millisecond has now got the additional call attached to that processing, and that might quadruple it, might increase it to 10 or even 100 milliseconds. And so then that's when you start having to go back to using partitioning to get that kind of additional parallel processing. Because if you're using the partitioning, then you're going to be, in this example, you'll be making 3 parallel calls because you're shrinking the amount of data that each query within Stream Analytics is having to process. So it's not, it's far, far quicker to actually achieve that. Now, the other thing to think about is when you're looking at this, what you may want to do if you've got millions of messages coming through is rather than use Azure Machine Learning, is literally just write this data out to something like Data Lake Store and then batch the actual machine learning element you need. A lot more efficient overall. And so you really start to need to think exactly where you want to put all of your capability. So let's look at choosing the data store. And at the same time, we'll actually touch on the batch layer processing because it kind of goes hand in hand. So first off, I mentioned previously the Azure Data Lake Store. So this has no limits. You can have files as big as you want. You can have as many files as you want. It doesn't matter. You've got proper control over the folders and structure. You've got proper authorization over Data Lake Store. You've got the encryption at rest, etc. All of the things that you want. And this, of course, will scale up to petabytes of data. And if we look at a little bit of the requirements that Data Lake Store was built on, the top one there was around security. One of the key questions people have is when they start using Azure Blob Storage is, it's not secure. This is, how can we do folder level control? You can't. It's container-based control. This is where Data Lake Store actually solves that problem because you've got full POSIX ability to control the actual read, write, execute on every single directory. Connects up to Active Directory, has that kind of integration built into it at the lowest level. And of course, so every time you actually run any kind of query over the top of Data Lake Store, it's maintaining that security. And scalable. This is designed from the ground up to be fully scalable. Azure Blob Storage, we all know, has limits. And so you may hit those limits and have to have multiple blob storage accounts attached to a HD Insight cluster. That all adds complexity to your job. Data Lake Store doesn't have that. I'll just skip to the bottom one here because these slides will actually go out. But a key area is around multiple analytic frameworks. If the storage layer doesn't support batch processing, real-time processing, streaming, machine learning, etc., then why would you choose it? It has to be capable of managing any form of data, any volume of data, providing the security necessary, and run any kind of compute layer over the top of it. And that's what Azure Data Lake Store does. So let's start looking at the actual data that's contained on something like Azure Data Lake Store. So the usual 3 types. We've got unstructured, we've got semi-structured, and you've got structured. Whenever you're building out a big data solution, you want to keep your raw data. Regardless of what you're going to do downstream, it is key that you keep your raw data so that you can then rebuild, reprocess at any point in time, and you don't lose any of that accuracy. And so that's where the unstructured piece comes in. You need to be able to store it natively. Semi-structured, you need to be able to manage that kind of JSON data coming through, XML, etc., Avro formats. And finally, at the bottom, we've got CSV and columnar. So downstream, you want to be able to make use of something like columnar storage. Now, you may ask, why would you need to do that? Well, we have columnar storage within SQL for the purpose of making it run quicker. And it's the same principle here. So we have different forms of columnar storage so that all column data is stored contiguously on disk. And so that way, when you're reading a single column, it's extremely fast. And you can perform things like vectorization processing, etc., over the top of it. So that way, this becomes extremely fast query. Now, the downside to this is you're having to convert your data into this format. And so that way, you end up with 2 layers of data. And that's something we'll touch on in a bit. So there are 2 formats available today that most people use when they start looking at columnar. First one is the ORC file. This was actually developed in cooperation between Hortonworks and Microsoft and the open source community. This is by far the best option for when you're using Hive. Now, you may not want to be using Hive, you may want to use some other format, but this does give you that vectorized execution that I mentioned. It gives you ASCII compliance, so you can actually perform insert updates and deletes on top of awk file data. Now, Parquet, even though it's fully supported in something like Hive, doesn't offer some of those other capabilities. But you do see Parquet used in preference when using against Apache Spark workloads. So let's just do a complete comparison between the Azure Data Lake Store and blob storage. So Data Lake Store, as I mentioned, it's completely optimized for analytics. Blob storage is not really. This is general purpose bulk storage. We have authentication, we have authorization, etc. on Data Lake Store. We have limited on blob storage because it's designed for the app to be an app backend. It's designed for backing up data, etc. Media storage, those kind of things. The other thing to note is you actually have it's a real proper file system or a hierarchical file system on Azure Data Lake Store. You don't have that within blob storage. It is a flat namespace. And a nice element is the fact we implement Web HDFS. So all those tools that are available today on open source Hadoop will work against Azure Data Lake Store, but not necessarily against blob storage. I say not necessarily. Some of them have been, they've added the capability to use the WASB drivers, etc., but it's limited. And both of these are now generally available, although Data Lake Store is only available in 2 regions in the US. It is going global. It's just going to take a little bit of time for it to actually go global. So now let's look at how we're actually structuring that data within the actual file system itself. So a lot of the time, we get asked questions around how we separate that storage into organization units. How can we bill individual users? You have to ask the question, is that the right thing that they should be doing? If it is, there's no reason why you can't have multiple Data Lake Store accounts and build them that way. But that loses the benefit of actually placing all the data into one area. And the best way really is to think about billing out separate HD Insight clusters or Azure Data Lake Analytics usage rather than billing out for storage and actually having a common storage environment that is paid for and shared amongst the different organization units. So getting that benefit of scale. The other piece really is around time partitioning. We're always asked, how do we create directory structures? Well, yeah, you might have the organization units on top, but the one thing you need to remember is to think about placing year, month, day, etc. as various different folders, so you can take into account, you make use of partitioning within Hive or Data Lake Analytics. If you don't think about that up front, there's actually quite a large, hefty cost to actually retrofit that afterwards. because you're having to go through all of your data and re-split it according to the new structure. So yeah, definitely consider that up front. And the third option there, paths should be obvious and self-documenting. I think that really says what I mean. But I've seen some customers where they actually use acronyms, they use obfuscation in their directory structure, and it becomes really difficult to actually make use of their system. You know, in the mainframes you might have been limited to 8 characters. You're not anymore. Use real names, make it self-documenting. So looking at that kind of structure, this is something that I would kind of recommend that you look to use as a kind of splitting the actual data. This is just one concept. There are lots of others out there that you may want to actually investigate for yourself. But essentially, what you're doing is you're having an environment for your raw data. This should be read-only to your developers. That's key number one. The only thing that can write to this is the automated operational processes that sourcing your data can write to this. And it should be, exactly as it says there, it should be in native format. Anything else is read-only. So your developers would read the data from raw, develop it, and do all of their processing they want to do in a staging environment. You may want to use other terminology if you want, but that gives them the flexibility to build out what they need to do, but still have access to all that data. And then when it comes to productionize it, you're then either going to run the job to move the data from staging to the trusted environment, or you're going to productionize the process to convert from raw direct to trusted. Now that trusted format, this is where you're looking at using Columnar. So your users are providing interactive queries against this. It's guaranteed, it's gone through some form of verification. There's been a lot of UAT testing and acceptance against the processes that you'll use. As raw data, when you're moving from raw data to trusted, you might only be looking to move a subset of that data. But this is the trusted data, the data that the users want to make use of with their queries, the data that your apps downstream would want to actually interact with, and the data that will then be moved across to your presentation layer. Now, it sounds easier than it actually really is. All of this takes time and effort to maintain, unfortunately. But it is something that you would want to actually set up and define up front, these kind of processes. And then the third option here is around data scientists. You want a sandbox environment. You want data scientists to basically have the ability to read from trusted, to read from raw, to have their own environment, literally go crazy within their sandbox, and do whatever they need to do to find that glimmer of hope around the data and be able to pull that into the next piece of trusted data moving forward, or the next KPI that the company is going to focus on. So they have to have that environment to be able to do that. And of course, then they may then write back to staging that then goes on to the actual core developers, and then that might then be made a trusted process downstream into production. So this is just one example. There are others out there. Definitely investigate the one that fits your company process the most. I've seen this work on a number of customer sites. It does work, but it also requires a little bit of rigor from your side. Moving into kind of the access characteristics, we have hot, we have warm, we have cold data. Now I'm just going to pause a second while you just take a look at the slide. But the best way of thinking about this is, when you're dealing with cold data, this is your raw data. You potentially have got petabytes of data here. You may have videos that you then process, and the processed data will then be moved into hot data or warm data, depending on where you actually want to actually query that. Now, hot data, because we require extremely quick, fast queries, you may be looking at a completely different service. This may not be Spark. It may not be Hadoop. It may not be Hive. It may be SQL Server. It may be SQL Database. It may be SQL Data Warehouse. It may be Redis. It could be a whole host of different things. And that's where we start to think about this kind of Venn diagram, where on the left, we've got the hot data. On the right, we've got cold data. And on the top, we've got low structure. So this essentially is unstructured as we go down to the bottom, where we've got some form of rigor around the kind of structure that's needed. So we've got SQL Server at the bottom there. That requires structure, obviously, unless, of course, you use JSON inside it. Then it becomes semi-structured. But, of course, there's different request rates. There's cost per gigabyte, latency. All of those kind of things need to be considered. And you end up with this kind of Venn diagram. And from here, you can actually then make a decision on the kind of technologies you might want to use. If you want really fast queries, and it's highly structured, using Redis on a cache, yeah, that may be what you want. That will give you, microsecond performance. It's all in memory. Or you may want to actually lose a bit of the structure, and you may want to use DocumentDB on NoSQL. Still extremely fast results as your presentation layer or your app layer that's ingesting the data. Now, this is just another table that gives you an idea of the different technologies we looked at there. So SQL Data Warehouse, comparing that with Spark, both of which, there's actually a mistake on this slide. It's not 60 terabytes, it's up to 60 nodes. So, and even that's going to be replaced in the future. There's so query latency. So SQL Data Warehouse gives you extremely low latency. If you can scale out and get the performance needed, you're going to be able to execute far quicker than Spark because you've got all the benefits of the SQL Server capability. Now, Hive, of course, Spark, of course, it's in-memory processing. So there are things that you might be able to achieve in Spark that you can't do in SQL Data Warehouse. And it becomes a balance of where you actually place your interactive query, or whether or not you use more than one. Why not? You've got all of your real data in Data Lake Store. Why not use different technologies for different things? And then size them according to that. And that's really where we move on into this piece here. So when you start looking at that kind of big data pipeline, you've got your Azure Data Lake Store where all your batch layer, your event ingestion is going into. On top of that, you've got your ETL, you've got your user queries. Now, when you start looking at this and you start sizing, most people think to themselves, well, I'm just going to have one Spark cluster to basically rule them all. Well, that's not really the way you should be thinking about it. So your user queries, you may need only 8 compute nodes running 24/7. As your ETL processing or your batch processing may be better off running on 40 nodes for 66 hours per day. And then at the end of that 6 hours, you collapse the cluster. And so 2 HD Insight clusters might be better than 1. And you really need to consider actually forming that kind of architecture. And Azure Data Lake Store allows you to do that. So you can have as many clusters you want, all running against the same big data store. So now let's move forward and about looking at the presentation layer or materializing for the interactive query, the users downstream. Now the first option might be SQL Data Warehouse, SQL Database. Those are nice cost-effective options, accessing via Power BI or Tableau or some other BI tool. But then why would you select Azure SQL Data Warehouse over SQL Database? So if your data volume is less than 4 terabytes consistently, SQL Database may be a good choice because you've got more T-SQL compliance in SQL Database than you have SQL Data Warehouse today. So that might outweigh the use of moving to SQL Data Warehouse. But if you've got, say, 10 terabytes of data, that's not going to work on SQLDB. You're going to have to use something like SQL Data Warehouse. Of course, which is massively parallel processing. You've got the ability to scale out to a petabyte of data, and of course that will increase over time as well. And thinking about SQL Data Warehouse, you can scale this up and down as you want. You can pause it, you can stop it, whenever you need to. So if your business users only use it from 9 till 5, well, only have it switched on from 9 till 5. Save the money. Don't pay for something you're not using. That's the whole benefit of moving into the cloud. And of course, transaction of SQL queries across relational. If you're using SQLDB, you're using SQL Data Warehouse, it is the same T-SQL. There's just a small variation in differences because it's massively parallel processing on one. It is still T-SQL. But as I said, SQL Data Warehouse is designed for analytical workloads, it stores large volume of data. Some people may decide that they don't want the big data in front of it. It is an option. I would say, moving forward, if you're thinking for a progressive architecture, that's probably the wrong thing to be doing. Certainly based on the customers that I meet on a day-to-day basis. So comparing data lake to data warehouse, essentially they're complementary. That's the best way of looking at this. And the data lake becomes the record of system of insight, or the raw set of data that you're using to drive the data warehouse data, which becomes your system of record. And the key difference here is that on data lake, it's schema on read. So you got your native data, you're applying the schema when you actually need to query it. As data warehouse, you're loading that data into a specific given schema, so it's schema on write. All of those things. And the key one at the bottom there is SQL Data Warehouse. It does give you predictable query performance. That's a huge benefit there. If you're using something like Spark, it can be a little bit unpredictable at times. So it complements each other. You're using Hadoop, you're using Data Lake Store, Data Lake Analytics, you're ingesting your data, cleansing it, you're performing using Azure Data Catalog to manage that data. You're performing advanced analytics, machine learning on the data within Hadoop, within Spark, or using Spark ML or Microsoft R over the Spark cluster. And then on the SQL Server side, that's for your BI users. The users who don't care about where it's come from, all they care about is this is exact trusted set of results that's going to give me the report that I need on KPI at Y and X. And so looking at that kind of business intelligence integration, on the right side you've got Polybase and SQL Data Warehouse that is connecting to your Hadoop cluster, whether that's via blob storage or whether it's via Azure Data Lake Store, and accessing that data, pulling it in, and integrating it into the SQL DW. So moving it from HD Insight. But then you have to ask yourself, what about Spark? So we've gone all the way through this topic without really mentioning Spark. But let's talk about it now. A lot of people today, they see Spark as being that kind of one solution. Because when you look at it, it runs on the top of Data Lake Store. You've got various different modules that give you the capability to perform interactive queries, say with Spark SQL. You've got streaming capacity there. You've got machine learning. You've got a graph processing capability there. But when you start delving into this, you need to investigate, is this sufficient for your needs? So looking at Spark SQL, it's not ANSI standard SQL, it's Spark SQL. It may not be sufficient for what you actually require on a day-to-day basis. A lot of the business intelligence tools don't connect in with Spark SQL, or they're not optimized for running on top of Spark. So those kind of things you need to think about. Spark streaming, it's very good at what it does, but then Apache Storm is actually better because it's more powerful. It's been designed specifically for that one task, as Spark is trying to be everything for everybody. Machine learning. So the ML lib, this is growing day to day. When you start looking at the algorithms, there's not many of them here that is actually parallel today, that runs in parallel across the Spark cluster. So that might give you not quite the performance expected. You compare that to say, the Microsoft R on top of Spark, that will give you much more parallelism with greater degree of algorithms. So that might be a better choice for you. But we provide this to you for you to make use of. We have Spark 2 on Linux. We're going to be following the Spark train as we move forward. We do see that this is something that customers want, and Spark 2 is dramatically better than Spark 1. So this is ever improving. The open source community is behind it with their full weight, and so are we. We've put back to the community hundreds of patches, both to Hadoop and Spark. We've made sure that the Azure Data Lake drivers are part of the actual project within Hadoop, so they're open source as well, fully accessible, so that anyone developing anything for the Hadoop platform can actually make use of the data lake. But at the end of the day, Apache Spark, it is a really powerful compute engine, and it is good for a lot of different tasks, and we shouldn't rule it out. But anyway, so putting all this together, so you may start off with a very simple pipeline. You got your on-premise data. You maybe just move this into blob storage. You may process this on HD Insight on top of blob. That might be sufficient for your needs today. And if you're in Australia, like you are, that might be all you get for the moment. Unless, of course, you're able to run out of the US. You may use machine learning as well on top of blob storage, and machine learning on top of Spark, and then push that across to Azure SQL. And that might be a good starting point. But then as you start moving down and getting more heavily involved in big data and Internet of Things and streaming data and all these various different things, your architecture is going to evolve. And this is something that you really need to consider. And so on here, we've got the streaming capacity on the top. We've got pretty much what was the old architecture in the middle, and then on the bottom we actually have the Azure Data Lake Analytics running off Data Lake Store, all of which can be fully integrated. So you can move from that architecture, the nice simple architecture, to this architecture very easily, because that's the whole point of following an extensible architecture. And you may decide that Azure blob storage should just be ripped out at this point and replaced with Data Lake Store when it's available in Australia. Personally, I would say yes, go ahead, do that. But the other thing to think about as well is managed services. Now, a lot of you, how many of you have seen this slide? I'm sure it's been, it's been around a lot. It's even got Windows Azure on the bottom, so it's been around many years. But it's a key slide to be thinking about, because you want essentially Microsoft to be managing more of this. So the more green is better for you. And so when you start looking at HD Insight, that's the platform as a service. All you're having to worry about is your applications and your data. Of course, how you deploy it, etc., that kind of thing. But those are the two key elements. It's a lot simpler. So that way, we've literally decoupled the data. We've built out on Azure a Lambda architecture. We've gone through a whole host of different tools, and we've shown the importance of managed services. Now, one of our customers, NEC, So they've actually been working with retailers. They actually have been placing cameras in stores. You might think, oh, privacy and all that kind of thing, but at the end of the day, it's a public space. You're walking into the store, basically given permission to do whatever you like to you, unfortunately. So they want to be able to see the gender of people. They want to see ages. They want to see the numbers so that they can better provide optimization for promotions. They may be able to get to the point where we're actually doing promotions on an hourly basis. So if you start seeing an influx of young people, your promotions will change accordingly. And that's only going to benefit the retailer. And on top of that, you've got all of the different cognitive services that you can make use of behind the scenes within your big data. So yes, it's a great example of where things are going. And I'm sure we'll start to see more intuitive solutions come out of this. So this essentially is the big data pipeline. Now, I've actually gone through this actually with some speed. I know it's the last session of the day, so I'm going to open it up to you guys for questions. No questions? Okay, please remember to fill out your session evaluations. You've got a chance to win a Spark After Dark drone, so please go ahead and do that. Thank you very much.